Hello. Hey everyone, this is my first time using Twitch actually, so if you can't hear me, post it in the chat, because otherwise I won't know. All right, so yeah, I thought today that I would just go through the sort of basics of the V3 contract setup. I have about an hour or so I do have to hop off around 2, but hopefully we can cover a lot before then. And yeah, I want to maybe just start with like a very brief sort of broad code overview, and then I think already there are some questions in the chat, and I definitely want to encourage that. And if anyone has stuff they'd like to dive into, I'd actually prefer that to just me rambling about the overall structure. So yeah, throw any questions in the chat. But for now, let me just do a really brief, like 5-minute tour or less of the code. So here I have cloned the Uniswap v3 core repo, which is public. And yeah, so I think the first thing to go over here is in the contracts folder, we have these 4 top level contracts. And the most important ones really are the factory and the pool. And so this is very similar to how V2 worked. The factory is responsible for deploying pairs, which are now called pools in V3, because in V2, pairs were sort of canonical. So there was a single ETH DAI pair. But in V3, because what used to be pairs can now have different fee levels, the ETH DAI pool can have a variety of different fee levels. So to start, you could have ETH DAI be trade at with a 0.05% fee, 0.3% fee, or a 1% fee, right? And so we call these now each pools because just because of that reason. So anyway, this factory is responsible for deploying pools, and so the real meat and potatoes here is this create pool function, which just takes 2 tokens and a fee, and then spits you out a pool. So it's really not too exciting. The one sort of unique, sort of somewhat interesting thing about this is that we have this pool deployer, and this is used for create 2 purposes. So this is really a little bit in the weeds, but what we do here is instead of basically calling a pool with constructor arguments, which would require hashing the entire bytecode in memory in order to basically calculate a deterministic create2 address, what we do is we use create2 here, which we use basically the new Solidity syntax, which sort of obscures the use of create2. In V2, the create2 opcode was sort of called directly, but in V3, Solidity introduced this new way of using create2, and so that is basically this braces, syntax here with a salt. And anyway, we need these parameters to be available. And so basically, in order to keep us from having to hash the bytecode, we don't have any constructor arguments for the pool, so that the pools are uniquely determined by token 0, token 1, and fee. And then what we do in the pool is we actually, what we're doing here is we're storing these like initialization parameters, what are basically constructor arguments, in this public struct here. And then in the pool, in the constructor, we actually like fetch these arguments, and I can show you that right now. So in the constructor, you can see here that we're like calling the pool deployer, and we're fetching this parameter struct, and then we're initializing these variables. And so this is all just a really hacky workaround to ensure that the create2 address is both deterministic, but also doesn't require you to hash the entire bytecode alongside the constructor arguments that are appended at the end, because that's how it would work if there were constructor arguments. So disabled notification, please. Yeah, I can hear that as well. I don't know if you guys can hear the notifications. Let me try to turn that off. Yeah, that is pretty annoying. If you guys can hear that. Do you hear that little like doo-doo-doo? Okay, let's see. Hold on. There we go. Okay, that should be off now. Sorry, that's pretty annoying. I didn't realize you guys could do that as well. Okay. Okay, no more notifications. Yeah, the music is not going away. The music is staying. It's for the vibes. Okay, cool. So hopefully that's enough for the factory and the deployer. Hopefully that makes sense. Okay, so let's get into the fun stuff, the pool. So yeah, so create pool. I'm not even gonna go over this stuff. This is pretty boring. I guess one thing to note before we move on is that this logic right here is what I was talking about with multiple fee levels per like token pair. So the first fee, like the lowest fee, is 500, which is basically 0.05%, so 5 bips. So the fee is 5 bips, and what this number here is tick spacing. I'll talk about that in a second, but the tick spacing for the 5 bips pair is 10. This one here is the 30 bips pair, so this is 0.3% fee. This is like normal Uniswap v2, and the tick spacing is 60. And then of course we have the 1% fee level pool, which is 200 tick spacing. And so again, I'll go into what tick spacing is later, but this is, if you were curious, like this is how the how those different pools work. And of course you can make more you can make more fee tick spacing pairs by calling enable fee amount, and governance is going to Uni governance is going to be able to do that. So cool. Okay, so let's move on to pool. So yeah, this is where the real heavy duty stuff starts happening. So you can see that we have these immutable variables up here, and these are exactly the ones I was talking about earlier from the deployer, right? So we have the factory address, of course, token 0, token 1, just like in V2. There's 2 tokens per pool, and then we've got this fee. Okay, and then here's tick spacing. So I think we should talk about tick spacing because it's actually pretty intuitive. And I don't want to talk about the implementation quite yet, but let's just talk about it on a conceptual level. So here, let me open up a little guy here. Okay, so let's pretend these are ticks. So this is the 0th tick, the first tick, the second tick, and the third tick. So ticks, like this is the timeline. And then we've got prices. Okay, so in V3, as you all probably know by now, ticks are divided up into, hey Alex, thank you, best stream, OMG. Okay, so in V3, hopefully you guys have read at least a little bit, enough to know that we've divided the price space up into what we're calling ticks. And so the price of an asset, of 2 assets, can be anything between 0 and infinity, technically, right? Okay, so we need to divide this price space up evenly. And so, the first very naive way to do this would be like linearly, right? And just like, the price of 1, the price of 2, the price of 3. That's actually really bad, right? Because the price of 1 to 2 is a 100% increase. The price of 100 to 101 is a 1% increase. So this is pretty bad, and there's general reasons to think that prices are not best sort of suited, or really linear space doesn't make sense for prices. Like a 1% price movement is what we sort of care about at all points. And so naturally this leads us to sort of like exponential ticks, basically. So we're ticks where, the next tick away is some percentage price movement away from the previous, right? And so the way we've accomplished this in V3 is exponential ticks, essentially. So what the price is for this 0th tick, so let's just, instead of prices, because I'm not gonna have room, let's just do the price like at 0th tick, which is right here. So the price at the 0th tick, and let's start with an easy example, the one that's not how the code is, but it's easiest to understand. So it's like 1.01 to the x, where x is 0. So, which is 1.01 to 0, which is 1, right? Let's do this for the first tick now. Give me a log spacing. Yes, Emiliano knows. I'm sorry, Emiliano. I'll start going faster soon. Okay, so this is 1.01 to the 1, which is 1.01, right? And then you can just basically very quickly see the pattern here. The price of the second tick, and I'll stop here, is going to be 1.01 to the 2, which is, I'm too dumb to do this in my head, 1.0201. 0201. Okay, so here you can see that prices at subsequent ticks are 1% away from each other, right? 1.01 is 1% greater than 1, 1.0201 is 1% greater than 1.01, and so on and so forth. And this basically can span the range. As long as you have enough of these ticks, it spans the range of all possible prices, right? And so what tick spacing is is a limitation on the number of on which ticks can on which ticks are allowed to reference a position. Essentially, is the easiest way to think about it. So at this 1% level, right, going from 0 to 2 represents a 2.01% price movement. From here to here is 2.0 plus 2.01%. If we, and in theory, like let's say an asset is expected, two assets are expected to be quite volatile, and like we're expecting, the average price movement, in a given interval to be like 5% or something, right? If we have ticks that are like 1% away from each other like this, any trade between those extremely volatile assets is going to end up crossing a bunch of ticks, right? And that's sort of bad because there is a small fixed cost for swapping across ticks, right? And so if we're starting here and like every single trade is making us go here and then here and then here and then here, we're going to have to cross these intermediate ticks like every single time, which is really costly. And so what tick spacing is it basically limits the number of intermediate ticks that you can add liquidity at. And so if we're, for example, not allowed to add liquidity at 1, and instead you could only add at 0 or 2, trades between 0 and 2 are basically, they don't have this fixed cost that's associated with crossing this 1 tick, right? And so now that you have the sort of framing, let's go back to the factory and look at these numbers again. So the tick spacing for the 0.05% fee pair is 10. And what that means is that we're actually only allowing every 10th tick to reference liquidity, right? And so every, there's one tick that might have a position at it, and then there's 9 empty ticks, which are guaranteed to never have any liquidity. And so you can smoothly transition by swapping, right, in between any of those 9 ticks. And so what this basically means is that it's sort of like a granularity parameter where it's how fine-grained you can be as an LP and how much sort of price space you can traverse as a swapper before you potentially run into a tick that requires some extra computation and some extra gas cost, right? And so the reason that these numbers scale up with the number of fees is because, as the fees increase, the reason the fee is increasing is because you're expecting the assets to be sort of more pairwise volatile. And so you need to sort of extract a higher fee in order to be compensated for your risk. And what that means also is that it's like what I was talking about earlier, trades between these two assets are expected to push the price sort of more than trades between pairwise, low pairwise volatility assets. And so you need more space between ticks because you need to like limit the gas cost overhead for swapping. And if swaps are expected to be sort of bigger and traverse more price space, then you have to sort of block away more ticks than for lower volatility pairs, right? So like stablecoin, ETH DAI, like the price never moves beyond like 0.95 and 1.05 or whatever. And so you need like really small ticks because you need to be able to express your preferences within that pretty small price interval, right? But for anything like ETH DAI, where the price can be anywhere from like 90 to 2000 or whatever, that's a much wider price range. And so in order to, like traversing every single tick between the price of 90 and 2000 would be crazy. And so instead, like in this 30 bips pair, for example, you're only allowed to, or at worst, you're basically only, performing tick transitions every 60 ticks, right? So that's what's going on here. Okay, let me quickly check. Yeah, so no real questions yet. Yeah, I mentioned gas fees a little bit. Okay, cool. So yeah, so that's tick spacing. Hopefully that makes sense for people. And yeah, I can actually, let's just finish this up really quickly by telling you what actually is in the code. So 1% ticks are too big, actually, unfortunately. So what we do is we use, well, I'll just leave this here. We don't mess it up. But like the real tick spacing in Uniswap v3 is like fake example with 1% ticks. Okay, so the real tick spacing is 1.001, and it's actually square root of 1.001 to the x. So, okay, this brings me, Emiliano says, no, a tick's lattice should have a fixed formula or can vary between price ranges. It has a fixed form, Emiliano. I think what you're asking is whether this is true across the price range, and it is. It's the same. It's a constant formula. But okay, this is the fake one. So let me go to the real one, and maybe it'll make more sense. So the real one that's implemented in V3 is this, and it's square root of 0.0001 to the x. So this is this is a this is 100 bips, right? 1% is 100 bips. This is a single bip, and it's actually the square root of a bip to the x. So the reason for this is a little complicated. So, okay, let's start with this. If we're just this, this would make sense to everyone, right? This is just like our example, except instead of 1% away from each other, each tick is like 0.00 or 0.01% away from each other, which is just a lot smaller. And this is a bit funny. Why are we throwing a square root in there? Okay, so the reason for this is actually not that complicated. It's basically that instead of tracking the price, which is just a ratio of two assets, right? We want to track the square root of the price. And that's for a very specific reason. But for now, just take it for my word that the square root of the price is a desirable thing to have. And so, this formula here essentially lets us be able to track the square root of price. And this distributes, again, in this like log space, it distributes square root prices 1%, percentage movements away from each other, like in this case, 0.01% away from each other. And so the reason why we want square root price instead of price is because it turns out that if you look at a lot of the math in Uniswap, like the x times y equals k math, you can express everything in terms of x and y, which are these like underlying amounts, but you can also sort of transform these formulas into square root price liquidity space. Okay, so let's like write x times y equals k. There's a lot, x is a token amount, y is a token amount, k is this like, unitless sort of liquidity number. Let me switch over to the white paper really quickly here, because this has the formulas. It turns out that, let me see, where's the pretty, yeah, here we go. So it turns out that x times y equals k can be reformulated in different terms. And these terms are in 6.3 here, if you're looking, let me zoom in a little bit. 6.3 if you're looking at the white paper. So this is L equals root xy, and root p equals root y over x. And so you can see that actually this is just a really simple transformation, right? If we're taking k to be like L squared here, L squared, then like square root x times y equals like L, if we're defining k as L squared, right? And so that's just what this formula is saying. And then similarly, you can do something with the price as well, because the price is just the ratio of assets. And anyway, once you have liquidity and the square root of price, you can basically calculate any number of transformations of x times y equals k. And in particular, right, like when you're swapping, all the swap is just like some transformation of this x times y equals k formula. And so, when I give a pool like one, DAI or one ETH, how does it know how much to give me back? Well, in V2, what it did is it just like took x times y equals k, it took the current k value, it like took how much you were sending in, it took the input amount off, and then it just like, calculated the minimum or maximum amount in or out that you could get, such that k would either stay the same or increase, right? In V3, it's a little more complicated than that for reasons that we'll go into later, but you can basically perform the same calculation, the same logic, but instead of using like input and output amounts, you can use liquidity and then square root of p, right? These two values here. And so we're tracking square root of price, which is what this sort of tick spacing formula lets us do, gives us this square root price form directly at all points. And it's what we can then use as inputs to calculate input and output amounts, for example. So I'm going to pause there. I'm going to read the chat really quick, see if anyone has any questions. Do ticks actually get further away from each other as it gets away from the initial price? So yes, in linear terms, right? The price of 2 is 100% away from the price of 1. The price of 101 is, or the price of 200 is, 100% away from 2. And so I guess the best way to say it is that the absolute difference between prices gets bigger as the prices get bigger, but the percentage difference remains the same. Emiliano says, clear, thanks. Basically, you optimize in another space like we do in fields. Yeah, it's just a space transform. So that's basically right. Is it correct that then the default tick spacing for the 30 bips fee pool will also be around 30 bips? Yeah. So we basically have picked the tick spacing based on the fee. We've doubled The tick spacing is double the fee. So if the fee is 0.3%, the tick spacing is 60. And that's, you correctly point out that it's actually a little more than double, right? Because you get this exponential increase. So, 60 ticks is more than a like 0.6% price movement or whatever, but only marginally more. And anyway, that's because the fee is like some kind of like a margin of error, right? You never really arbitrage to the true price. You're always arbitraging to within the fee, more or less. And so making the tick spacing double the fee sort of has these nice properties that, you can, it just sort of, it's this nice property. Okay. Bandit says big slam. Hello. Okay, cool. So I think people get it. I'm going to move on a little bit. Okay, so to contextualize this L and square root P stuff, I think let's dive into a function that will make this a little more clear. So I'm going to go into libraries here, and I'm going to click into square root price math. So which is the easiest one to explain? Okay, here, this one's easy, right here. Okay, so don't worry about how this is used or where this is used, but if you're worried about, or if you're interested in thinking through how these square root prices and liquidity values can actually give you like meaningful inputs and outputs, this is an example. So this get amount 1 delta takes in a square root price, which is this first parameter, another square root price, this one, a liquidity amount, and then just like some rounding parameter. And it returns an amount. So, okay, so what's happening here is that we're actually calculating this very simple formula, right? It's the square root of an upper price minus the square root of a lower price times liquidity. And so what you can see here is that we're just sorting the parameters in case they're not sorted already. And then depending on whether we're rounding up or down, we're just multiplying liquidity, the difference in square root prices, and then we're dividing out for fixed point numbers. But what this is basically saying in sort of English is that for a given price range, like let's take, for example, here, let me split this. You can see both. So in my example here, right, the price, the tick of 0 has a price of 1. The tick of 1 has a price of 1.01. So imagine we pass the price of 1 and 1.01 to this get amount 1 delta function. And then we have some liquidity amount. Someone has added liquidity between 0 and 1, and it's some amount. What this function does, get amount 1 delta, is it calculates how much of the token 1, which is just like the denominator asset instead of the numerator, or vice versa, it doesn't really matter. But how much of that asset is required to be fully solvent as a liquidity provider between 0 and 1, right? And so if you imagine a swap from 0 to 1 against some like fixed K, like some fixed liquidity amount in V2, maybe in V2 terms, how much would you need? How much liquidity, how many assets would you need in between the 0th and the first tick in order to be fully solvent as an LP? Well, this function actually just gives it to you, right? It takes a lower price and an upper price, and an amount of liquidity that you're like interested or thinking about providing, right? And it spits out the amount of token that you need in order to like fully cover this position. So yeah, ultimately that's like, and this is basically a square root price. This is another square root price, and this is liquidity. And so you can directly see how these liquidity and square root price values that we're actually tracking can be transformed really directly into like actionable things that the pool needs to sort of take take these values and then transform them into inputs and outputs. So, okay, cool. Hopefully that is enough background. I'm actually going to check why my music is off. There we go. Okay, cool. So let's dive into the code a little bit more now that we've sort of gone through the overview stuff. Yeah, I'm playing the background music, CryptoZen. Apologies. That's yeah, that's my choice. So you can here. I'll turn it. I can turn it down a little bit. Okay. All right. So let's look a little bit into the code here. So now that we've gone through the ticks and how tick spacing works, this mint function might make a little more sense to people. So the very first thing that you want to do in a V3 pool, right, is you want to mint some liquidity. And in V2, this is quite easy, right? You throw some assets at it, it'll give you back some liquidity, and you're a liquidity provider over the entire price range. In V3, it's a little more complicated, right? You can't just, you could in theory do that, right? You could just provide liquidity for the whole range, but you sort of would want to take advantage of this like capital efficiency multiplier that V3 offers you. And so what the mint function in V3 is it basically takes a tick lower and a tick upper. And so I closed, unfortunately, I closed the little tick diagram, so sad. But the tick lower, the tick upper are just those like ticks that I was referencing, like 0, 1, 2, 3. And those correspond exactly to square root prices. And so you're basically picking the real world prices of these assets that you're willing to provide liquidity between, and then you mint that liquidity in it. It actually uses that get amount 0 or get amount 1 delta function that we went over just previously to sort of calculate how much of the underlying asset you actually need to provide. And so you can actually do that in the reverse too, right? Like if you have 10 DAI and like 0.1 ETH or something, and you don't know, like no one knows how much like liquidity they need to provide, because that liquidity is like, again, as I mentioned, it's sort of unitless and it's a bit funky, but they know they have 10 DAI and 1.1 ETH. And so you can actually, from an underlying amount and then a given price range, you can also calculate the maximum amount of liquidity that you could possibly add. And so that's another way, and maybe a more conceptually like intuitive way to understand what the liquidity amounts actually represent here. And so the more sort of the tighter price range represented by the smaller delta in these lower upper ticks, the smaller the price range, the less liquidity you have to contribute the less underlying tokens you have to contribute to get the same amount of liquidity. So that's what this mint function does. Pretty straightforward. We won't go to the implementation just yet because it's a little more complicated than the interface. We have collect, which is once you've minted a position and there's been some fees that have been earned, you can sort of collect your fees via this. And then of course there's burn, which is removing liquidity essentially. So again, it's parameterized by these same upper and lower ticks, and you can burn a particular amount of liquidity. The lead asks, lowest tick difference is 1. So yeah, as I unfortunately deleted the thing, but the ticks, the smallest tick possible in Uniswap v3 is 1 BIP, so 0.01%, which is this number, right? And that is, that's the smallest sort of granularity of tick. Mario asks, can you later, let's go to Colton first. Okay, Colton asks, might be unrealistic, but could there be 0 liquidity in a particular price range? Yeah, Colton, there can be, that's smart. So, right, like, yeah, in theory, maybe there's, I've provided liquidity from like tick 0 to 5. Someone else has provided from like 10 to 20, but 5 to 10 is empty, right? So in that case, what can happen is if the current price is like 2 and you need to push it to like 15, you'll need to traverse this like 0 liquidity space. And so that is actually totally possible in V3. What happens is that you essentially swap to the very end of the range of non-zero liquidity. So you'd swap all the way to the price of 5, right? And then all the liquidity would sort of exit, right? Because that's the end of my range. And then you'd basically be able to traverse the space from 5 to 10 for free. And then at 10, you resume swapping in the positive liquidity region again, right? So so it's basically free to traverse 0 liquidity regions. I mean, there's a small caveat and there's a small like gas overhead rather to this, but you can basically traverse the entire price space if there's no liquidity anywhere for free in a single, like easily in a single block, right? And so there's no like, DDoS ability here or anything like that. And yeah, it's basically free to traverse those spaces. So hopefully that answers your question. Okay, now Mario, can you later dive into how the tighter bounds result in more liquidity? Code-wise, conceptually, it's clear. Code-wise, got you, I will. Hey Mike, what's up? There are accumulation points for swaps, Emiliano says. Yeah, that's right. There are these ticks, which are, they represent the minimum, the tick spacing controls the minimum sort of distance that you have to travel before you might be forced to pay this like overhead gas cost for transitioning ticks. Okay, so let's jump into this this tighter bounds result in more liquidity thing. So I actually think this might be a total disaster, so bear with me. But I think I'm just gonna modify one of our tests to show you in like very concrete terms how tighter price range, providing in a tighter price range means you can provide less liquidity, provide less underlying for the same liquidity. So let's dig into this. So I actually had pulled this up earlier, so this is good. So I'm gonna adopt only this test, so it's the only thing that runs. And what's happening here is we're just minting some liquidity within a range as the first position, more or less in a pool. And so what this test is doing currently is it's saying, I want to mint 100 liquidity, and it's testing that the cost of minting that liquidity is 317 of token 0 and 32 of token 1, right? And so let's just run this. I can type yarn test here. and it's a little slow, so bear with me. But we're just going to make sure that this actually runs as is. And then while that's running, I'm going to do something else. Yeah, see, it's really slow. Yeah, my computer is chunking right now. Sorry if the stream is like laggy or anything. Okay, there it goes. Okay, great. So it passes. So now what we're going to do, and I'm just going to run this because it takes so long, but we'll talk about what I changed first. Okay, so now what we're going to do is after this one, we're going to add 100 liquidity again, right? So we're going to add the same amount of liquidity. And if you want to think about liquidity, like liquidity is sort of a common denominator, and you're able to, it basically determines how much fees, how many pro rata fees you get, right? And so 100 liquidity that's in range earns the same amount of pro rata fees as 100 liquidity of anyone else's position. I mean, the caveat here is right that if you provide liquidity in a smaller range, your 100 liquidity isn't going to be in the pool for as many prices as the other person's 100 liquidity, right? But in theory, while the price is in the range of both of these positions, you're earning 100 liquidity. I'm actually realizing though that the price is not 1, so this won't even be in range. Okay, let's see what the current price is. Sorry, this is a little annoying. Okay, so it's the price is 1 to 1 over 10. All right, this is a little annoying actually. Well, anyway, let's just do it out for the sake of example. Okay. Okay, while this is running, what IDE are you using? VS Code, yes. Mark said, how are we going to be able to use the flash swap function within Uniswap to balance fees if they're blah, blah. Okay, interesting. I can talk about flash swap. I'm not sure exactly what you mean by flash swap for rebalancing. You can definitely automatically rebalance your positions, but I'm not sure how that has to do with flash swaps. VS Code theme, great. I don't. Yeah, okay. I'm not going to run the tests anymore. So, all right. So basically, let me just mock out what it would be. So like, what this is doing is adding max range liquidity, right? And it's saying this is the cost to adding 100 max range liquidity. If I want to add the same amount of liquidity, but in a super tight range, so this tick spacing is like really small. This is like 10 ticks. This is like 8,000 or yeah, like 100,000 ticks potentially. This would be like 31, and this would be like 3. So what this is saying is that like the amount of underlying you have to contribute to get the same amount of liquidity is like way less if you scale your price range down, right? And so all this is saying is that these two positions rather, are going to earn the same amount of fees while the price is within tick spacing, minus tick spacing to plus tick spacing. But this person only had to contribute 31 and 3, and this person had to contribute 317 and 32. I mean, these numbers are fake because like whatever, the tests are chunking my computer, which I'm not going to do anymore. But yeah, that's where the capital efficiency comes in, right? But this position is way riskier because the price could easily move beyond minus tick spacing to tick spacing because that might be only like a 1% or 2% or something price movement, right? So hopefully that helps. Everyone's saying the stream is chunking. Sorry, hopefully it's good now. I stopped the tests. Will Uniswap v3 enable paying arbitrary fee from LP fees to an arbitrary address? Yeah, you can pay fees anywhere. That's totally arbitrary. Can you talk about LP layering, i.e. overlapping ticks? Yes, Rockmore, for sure. So yeah, the coolest thing about V3 is, right, these positions, like let's go back to Mint. Okay, so yeah, Mint just takes this lower and upper tick, right, and it's linear. Like your position is, it's flat over the tick range. But yeah, you can stack these to form basically any arbitrary distribution. And so if you wanted to emulate like Curve or StableSwap or some balancer non-equal ratio or whatever, you could basically do that more or less via like any number of sort of ranges with different amounts of liquidity in them. And so Hayden actually tweeted like examples of like a Riemann versus Lebesgue or something integral. And so that's like, it's in calculus, you can like calculate the integral of something with like stacked horizontal bars or stacked vertical bars. And so in theory, you could like make positions that stack like this, or you can make a bunch that are like in individual, sorry, the camera's here. Like you can stack like vertical positions like this, or you can stack horizontal positions like this. And then you can sort of simulate any distribution of liquidity within whatever price range you want. And so, yeah, there's some fixed costs, of course, to like initializing these and then rebalancing them if the price shifts and you want to like maintain a normal around the current price or something. Oh, that's loud. But yeah, this lets you basically fully, flexibly, fully arbitrarily emulate sort of any curve you want. And so the sort of small gas overhead is probably worth it. But yeah, that's how that works. Wow, there's a lot of questions. I really got to get through these. Okay, what's the cost and process for rebalancing that portfolio? I sort of talked about that. Freddie, this is recorded. There's going to be a VOD. So don't worry if you're like, if you want to follow along later. Tighter bounds will result in more liquidity than wider bounds. Yeah, that's right. For the same amount of underlying. And that takes care of pro rata fees. Exactly. Yep. Because yeah, you got it exactly. The pro rata-ness of fees is determined by like the liquidity amounts. Big fan of your work. ETH2Dev here. Hey, Raul, what's up? I use Prism. ETH2. Woo. Okay, what were the hardest bugs you had to overcome? That's a good one. Let me save that one actually for, I want to try to get to make sure everyone's questions. So let me, hardest bugs. Actually, no, let me just talk about it really quick. It's kind of fun. Okay, so the hardest absolute bug, or like at least on a meta level, there's a bunch of like small ones, but the biggest like high level bug was that when we first started on V3 Dev, we were thinking about everything in V2 terms. And in V2, token amounts were king, right? The amount of X and the amount of Y, the amount of DAI and ETH in a pool was like everything. It determined everything. And so what we did in V3 is we tried to like copy paste that logic into a world where liquidity no longer is like backed one-to-one essentially, right? Or at least it's no longer backed one-to-one at all prices, right? There's like this virtual liquidity, value, which you saw in the previous example where, the people contributing 100 liquidity each were contributing different amounts of underlying, right? And so you have to, in V3, you have to transform your idea of like liquidity, meaning underlying amounts, into this like kind of virtual price or this virtual liquidity space, which varies depending on what the price is. And so the initial V3 implementation used these virtual liquidity amounts of X and Y in order to perform all calculations. And it was a total nightmare because what happened is that when you wanted to swap, you often need to round like one way up or down, right? Because the EVM is like uses int math. And so this would result in the price changing, right? Unfortunately. And because the price is extremely important to be precise, right? Like we have to be able to swap exactly to a particular tick boundary because that's like a solvency condition, right? You've added liquidity between the price of 0 and 1. And if we aren't able to get exactly to the price of 0 and 1 based on these virtual liquidity ratios, like that's awful because there's like a solvency problem there. And the rounding was just a total nightmare. So the way around this is that Dan Robinson, one of our investors, basically came up with the idea of using this liquidity square root price transformation of the X times Y equals K formula that I presented earlier in the stream. And that basically solved all our problems because it let us track square root price imperatively, right? Like before we were sort of like letting it be derived by the ratios of X and Y, like the square root of the ratios of virtual X and virtual Y, which like already me saying it sounds like a disaster. And it was, but by tracking square root price sort of imperatively and just transforming it along the curve as swaps happen, as liquidity gets added, whatever, this let us like really simplify a lot of that math. And so I think that's one of the biggest, maybe it wasn't a bug, but like it was leading to a lot of bugs and it really helped the process, the development process. So yeah, so that's, hopefully that answers your question. Okay, sup boy, it's your boy Clement. Hey Clement, what's up dude? Thanks for tuning in. What happens if the price reaches a place where no liquidity? I covered that earlier, Stump and Dump. You can check out the VOD. Michael, what's up Michael? Does the non-uniform liquidity curve mitigate sandwich attacks? No. No. The sandwiching is sort of like a trader specific thing. I mean, there is this like, there is this ability to sort of add liquidity before and after trades. But no, the curve stacking doesn't sort of directly mitigate or exacerbate sandwiching. Okay, how do you see keepers like Urine approaching passive LP position? Yeah, this is a good one. So let me just quickly touch on this because I'm not the expert here, but yeah, in theory, right, you can approximate any curve, but you might want to like change the parameters of this. So Curve had a tweet about this, right? Like Curve, the AMM. Sometimes they like tweak their parameters for different pools if like the volatility changes or something. In V3, you can't like tweak a single parameter to get all positions to change and behave differently. But what you can do as an LP, if you're like mimicking some position and you want to like adjust a volatility parameter, you can sort of like rebalance that position. So in theory, you don't have to do this as an individual. You can like follow a strategy that does this. And the Uniswap V3 oracles, which are actually so much better than V2, like way better, they can let you access like on-demand spot prices, and you can also do like historical volatility calculations. So yeah, in theory, I think it would be dope to come up with like a shared like normal distribution strategy, something like that, around the market price. And every like week or every day or whatever, you could like rebalance that based on-chain TWAPs, and you could sort of shift that position. And you could basically, instead of, and unlike Curve where you're locked into, and I'm not hating on Curve, but if you're like locked into a particular parameterization of the curve, that's basically it. But in V3, you can like do any arbitrary parameterization, and then the flip side is like, because that's so much better, there is like a downside that you have to normally like manually rebalance, but it's still super powerful. So that's how I see sort of Yearn and Yearn style stuff fitting into the V3 world. Okay, I gotta go faster. Do we incentivize somehow LPs to fill holes? No, Emiliano, that's just gonna be like, it's just gonna be expected. Like, you're gonna wanna earn fees for valid prices. There's gonna be arbitrage opportunities. It's gonna be like that kind of thing. We're not gonna incentivize hole filling. Mark Ansted says, I was thinking of it in the sense of flash loan to be able to rebalance your position as an LP. Oh yeah, I see. Yeah, you can rebalance. You'll just have to, it's just like manually rebalancing. Yeah, and you can use flash loans potentially to, like if you need to swap before, before, like as part of your rebalance, like maybe you could use a flash loan as part of that. So yeah, that totally makes sense. Waffle Bug, there's a VOD, so no worries. Okay, Metcalf is law. For the same capital investment, LPs that can more tightly follow the current price will earn a better ROI. Yeah, sort of, but you also, there's no way to predict future price, right? And so the tighter your position, the more IL you'll face, right? And the more you could potentially get really hammered by loss. So yeah, like in theory, if for every single trade, you're always providing like max levered liquidity around the market price, yeah, like sure, you're going to earn a lot of fees, but it's also ultra risky to do that. So yeah, it's a trade-off. It's a risk trade-off. I've been studying Uni V2 because I've been working as tech support. Curious to watch the rewatch. Yep, cool. Wow, there's a lot of questions. Okay. Do you think Uniswap will now make gas prices even higher because in addition to swapping, people will also change their liquidity position? No, I don't really. Yeah, there's going to be a little bit more overhead to changing liquidity positions, but yeah, swap costs are a little lower for most trades than V2. And yeah, there's this small overhead, but like I mentioned earlier, there's this like Yearn style batching kind of pattern that can happen, which we're definitely expecting. So, that's going to mitigate that to a significant degree. I heard there's a front routing opportunity when removing and re-adding liquidity at different price ranges. Is that true? No, not really. So when you burn liquidity or when you remove liquidity, there's actually no way to sort of screw someone over, because if you agree with the current price, right? Like you're removing liquidity at the price of whatever, and that determines the ratio of assets that you get out. If you agree with that price, changing the price just gives you more of one of the assets or the other, right? And that's just like inherent to how Uniswap works. Like as you trade away from the market price, you're getting inherently worse rates if you believe the market price is the true price. And so if you agree with the price when you're burning, and it changes, you're only ever getting more out in relative terms. Like if you can think about it in dollar terms, you're only ever getting more out than you wanted when you withdrew. So yeah, you can't get front run in that sense. And with adding, you just make sure to specify your slippage just like any other trade. So yeah, there's no, I don't think that's right. 1inch has brilliant routing, but a gas cost. When a pool is split into, yeah, so there's this gas cost problem, there's a routing problem, but we have, I can't say too much, but we've got ideas about that. So how much will this last with Twitch? Yeah, hopefully, okay, we have some time. We have like 20, 30 more minutes. So yeah, layer 2 integration. I don't actually know too much about that. I do, but I'm not the layer 2 expert. So yeah, that's more on Optimism's timeline than ours. Hey everyone. Hey, okay, so do you expect reduced profit opportunities for people doing ARBs since smart liquidity will just bounce according to market price? Yes, kind of. So I think that like our expectation is that slippage is going to be, price impact, which is distinct from slippage. I can go into the details if people are interested, but price impact, meaning like how much your trade pushes the market price based on current liquidity, that's going to dramatically decrease with V2 because you're going to be able to like scale up your liquidity provision. So where a trade of like 1,000 DAI for whatever ETH in V2 might be associated with like a 0.1% slippage, we're expecting that to be associated with a much smaller price impact. We're expecting that to be associated with a much smaller price impact in V3. And so you're going to get better execution by virtue of that, just that fact. And that's going to lower the arbitrage opportunity, right? Because you've pushed the price way less far from the, quote unquote true value. And so the arb profits are much less. Hi, thanks for this Twitch. Do you expect the V3 LP side to become a new bot or scene? Yeah, look, I mean, there's always going to be bots. We're not like, we're not trying to, dance around that. There's going to be automated liquidity provision for sure, maybe to a slightly higher degree than in V2, but ultimately, I don't think that ultimately there's still going to be a place for passive LPs, and especially in the context of these like auto rebalancing strategies. And you can also still, there's definitely there's still ways for non-bots, I think, to contribute liquidity and be very profitable. So that's what I'll say on that front. Any tips on becoming a good Solidity developer? Lots of time and reading the Solidity docs. Is there a plan to internally develop a contract to break NFTs into ERC20s? Yeah, we don't have any real dev work on it yet, but we've thought about it a lot, and it's definitely possible. And this is one of the areas where we're also looking forward to the community to come in and sort of like have these novel fee reinvestment, fungible liquidity strategies. Because there's no right answer, right? It's sort of an opinionated process. And so yeah, we're expecting absolutely many of these to sort of pop up. And we're also probably going to start, after the initial launch, we're going to start working on this as well. So, any impact on pathfinding of the router, or does the router still exist? So Mako, yeah, routing is still going to exist. It's not that much more complicated now. The routing smart contract infrastructure is already there in the periphery contracts. So right here, swap router, like this swap router contract in Uniswap v3 periphery just handles exact input and exact output swaps just like v2 across any number of pools. So yeah, that's already working. The front end story is a little bit more complicated, but like, yeah, it's going to be ready by launch. And there's also more stuff coming beyond an MVP that we're excited about. So, okay, I'm almost caught up. Won't gas costs associated with constantly updating on-chain ranges make small LPs not viable? $30 to change my $100 LP position range. Yeah, Dingus, for sure. But the real answer here is that if you're going to be like, so yeah, there's two answers. If you're a small LP, you can definitely just provide within a slightly wider range and like be a bit more passive, and you'll still earn hopefully reasonable fees. But the flip side of this is that you can also participate in one of these pooled Yearn style strategies, or Yearn, I don't know what people say. That auto rebalances for you, right? And it just batches a bunch of small LPs, and adjusts your positions on a wholesale basis. So yeah, that's definitely a possibility. And of course, there's the L2 story as well, right? Where like hopefully this is cheaper on L2, and then hopefully there's liquidity on L2, and you might be able to, that might be a more profitable place for you to be. Ooh, I caught up. Okay, sweet. Hopefully people are enjoying this. I don't know. I wish I could like see how many people. I guess it's fine. Julio, is there an equivalent to get amounts out? Yeah, so maybe we can go into that really quickly. The basic idea is actually really simple. Okay, so let's go into the swap function here. So so the way swap works is it's a while loop between initialized ticks. So it's basically saying like, while you have enough output amount to swap, or input amount, enough input amount to keep swapping, or you're still like desiring some output amount, it'll perform a single iteration of swap. And an iteration of swap is basically like, given the current price and given the most, like the nearest tick below and above the current price that has liquidity that's referencing it, it lets you swap, fully freely within that range up to either of those, that min or max tick boundary. And basically the reason for this is because once you've reached a boundary price for which liquidity, any amount of liquidity is being kicked in or out of the pool, you need to like perform that transition essentially, right? And so You can swap freely to a min or max, the next up or down tick with liquidity at it. But once you've gotten there, you need to stop swapping. You need to like perform this liquidity transition and then keep swapping. And so if you want if you want to send 1,000 DAI in and you want ETH output, but 10 ETH or 10 DAI is only like the most you can get up until the next tick is like 10 DAI. You basically send that 10 DAI in as the first iteration of this while loop. You get to that ending price, you perform the tick transition, and then you swap the rest of your like 990 or whatever DAI into inside of that next range. And so get amount out is a little bit more complicated, right? Because you can't just it's not parameterized by just two variables anymore, like in V2, the X and the Y amounts. You actually need potentially not arbitrary many, but like you potentially need as many tick values as there are ticks in the whole space, right? Because if you're at the min price and you're sending a bunch of input amount, technically you could traverse the entire tick space. So you potentially now need up to like 100,000 ticks worth of data to do that. But in practice, of course, this is going to be way smaller, and you're going to need only a couple ticks worth of data to sort of quote any trade size up to some threshold. So I love you, Noah. Thanks, Janaska. Oh, Ian-A-Z-K, probably AZCH. Okay, when testnet? Yeah, we're thinking about testnet. So we want to make sure that the periphery, which is not quite code frozen yet, is like in a solid enough state. We think that we want people to use stuff in like local testnets, Ganache and Hard Hat and stuff. So yeah, do that for now. We're probably going to do a testnet before launch. I mean, almost certainly. So yeah, hopefully sooner than later, but not yet. What happens to V2 contracts with the launch of V3? V2 router won't be able to interact with new pool contracts, but V2 will of course be around forever. And so if people like V2, use V2, that's fine. But we think V3 is cool. So cool, okay. Well, this is good. I mean, we're caught up with the questions. Is there anything else code-wise that people want? So I don't know. Like I can go into ultra specific detail here on any of this stuff. Probably way more than people want. But I also don't know if that's interesting or sort of what to focus on. Yeah, I've sort of covered most of the interesting bits from my perspective that are high level. So the remaining things would be like pretty low level. Maybe the Oracle is worth talking about if people don't have. Yeah, the Oracle is dope, Bakamore. So let's do that real quick. But before that, Hard Hat your first choice for testing, etc. Yeah, Hard Hat was way better than Truffle. Let's put it that way. Okay, so the Oracle. So let's first go over the top level data structures, right? Just to get your head around things, and then we'll go into the implementation. So the top level data structures for the Oracle are, where are they? This guy right here. Okay, so it's this array, right? It's an array of length 65,000, which is 2 to the 16, called observations, right? And that's it. So each observation is an oracle.observation. So if we go into Oracle here, we got this struct, which is an observation. So an observation is a block timestamp, right? When the block was. The tick accumulator at that point, the liquidity accumulator, and then this flag. So I'm going to assume some familiar with V2 oracles. V2 oracles essentially track a cumulative sum of prices, meaning the X over Y over time, and then it just lets you take deltas for any interval, and then back out the average price over that interval. In V3, prices aren't as important anymore, but instead the square root price is. And what's even easier than a square root price is a tick, right? And so moving from prices to square root prices to ticks is like the natural progression that we took when we're thinking about V3 oracles. And essentially what we settled on is tracking cumulative ticks instead of cumulative prices. And what a cumulative tick lets you do is basically with tiny loss in fidelity, which is more than acceptable. It lets you limit the amount of space you need to store this, but still lets you track average prices over intervals. And so you'll notice that this is an int56, which is pretty small. And that's because ticks are 24 bits wide. and then you need 32 bits for the timestamp. But a 24-bit tick is enough to represent, the maximum sort of span of possible prices in V3, and so it's very it's very expressive in that way, but it's also quite compact because it's in log space. So yeah, that's the first thing to say about that. But anyway, we have an array of these, right? And so when a V3 pool starts, it gets initialized with this guy. Basically, the first element in this array gets initialized to like a starting observation where everything is zeroed out. And then what happens is that every subsequent block, the first swap or mint or burn of that block pushes or overwrites an array item in observations. And so what that means is that the array length starts at 1, right? So the first observation is this dummy, and then every subsequent block, a swap will just overwrite this observation, right? And it'll just change these values and nothing else, right? But anyone can at any point come along and call increase observation cardinality next, which is a bit of a mouthful, but what that does is it increases the array length from 1 to like any number up to 65,535. And that function exists so that you, as the caller, can sort of take on the gas costs of this Oracle array length increase without sort of burdening swappers or minters or whatever. But once they've done that, right, once the array length is like 10, say, instead of overwriting that same observation again and again and again and again, what happens in right here is we basically track an index that cycles along this array, and we start overwriting observations in reverse chronological order. So once 9 blocks have elapsed since someone bumped the array from length 1 to length 10, there's now 10 observations, the 10 most recent blocks at which you can access the liquidity or tick, the cumulative liquidity or tick values. And then, so at any point, within that entire time period, you can calculate exact average prices, right? And that's done with something that we call observe, which takes an array of seconds ago. So 0 seconds ago, 10 seconds ago, 20 seconds ago, 60 seconds ago. And what it does is, as long as the array length, the Oracle array length, is long enough, it does a binary search over existing observations, and it returns you the accumulator values as of that number of seconds ago. And so in theory, you can bump this up to 9 days. So if you bump it up to 9 days and then 9 days elapse where there's a trade every block or whatever, then you can just query arbitrary periods within that time frame and get exact average prices, which is super powerful and super cool. And the binary search that we implemented to get the the value or observation as of X seconds ago is pretty cool. And so I definitely recommend that. I'm not going to go over it now, but I definitely recommend you guys check that out. It's called binary search inside of Oracle.sol, and this thing ate my life for 2 weeks. So I hope you appreciate it. But yeah, it's a cool feature for sure. Okay, let's go back to questions. Is this the only Solidity contract that has a while loop in it? Yeah, the while loop is insane. It was a total nightmare as well to get right. And yeah, formal verification tools hate it. So yeah, it's probably one of a kind or close to it. So, but it does work. So will ZK Sync be supported on L2 also? We're planning only on Optimism at the moment, but that could change. You should check out ATVM dApp tools. Yeah, I've been meaning to get into dApp tools and ATVM. This was sort of, the hard hat stuff was easier to get off the ground for us, and then we just had too much inertia. But I hear you, and I've used it a little bit, and it's sweet. I have a question from a design perspective. How do you come up with new design, user feedbacks, considerations? Yeah, Dan is actually really helpful with this. So Dan is really, if you guys don't know, Dan Robinson, the total mastermind behind a lot of this stuff. And yeah, he's really plugged into the AMM design space, along with Tarun and Guillermo and Charlie from Paradigm as well. And so that sort of group does a lot of thinking and sort of design work around the future of AMMs. And so I think that's where a lot of the inspiration for this stuff came from. But yeah, we're always, of course, worried about user experience as well, and developer experience, because we want developers to be able to build on top of this. So yeah, it's sort of a team effort all around. But okay, I saw your thread with Doggy though. Okay, I don't know what that means. That's fine. How much gas does it cost to initialize 65K checkpoints? Good question, Will. So yeah, 65,000 checkpoints, right? Times 20K gas, because it's an S store per, observation slot, because they're one word each, which is, we worked very hard to make sure that happens, is 1,000, a million, a billion, 1.3 billion gas, which is like, the current block limit is like, what is it, 16 or 15 million? 1, 2, 3, 4, 5, 6, one more. So yeah, it would take 86 blocks full of initializations to get a fully maxed out observations array, which is a lot, right? And it's really expensive because, like, this is like times 100 way times like the ETH price over 29, right? $195,000. I think that seems roughly right. So yeah, it's a lot of money, obviously, but like for ETH DAI, with like liquidity that supports like millions of dollars of trade with like really low slippage, we think this is probably a valuable amount of data to have, and so it's probably worth someone paying 200K at like 100 way, which is probably not even enough to get you into the blocks at this rate. But anyway, yeah, that's how that works. Why the square root prices? So I went over this Metcalfe's law. I went over this earlier in the VOD. I sort of recommend watching that, but also you should check out the section 6.3 of 6.3 and 6.4. I guess it's 6.2 is what it is, of the white paper, because this really explains like why square root price. I have a contract that flash swaps ETH into Link using V2 router and the V2 ETH Link pair contract. Will there still be liquidity within the V2 contract? Yeah, we don't know. People are going to migrate at their own pace for sure. V2 pairs might be around for a while. People might want to migrate out immediately. It's not clear, but certainly you're able to use V2 like into perpetuity, and V3 has like all the same features and more. So including flash loans, right? So the API is a little different, the interface is a little different, but yeah, ultimately, like you'll be able to use whichever or both has liquidity. So learn this one trick the purple verifiers hate. Pretty good. Okay. What lower and upper tick value should I specify to provide liquidity on the whole price range, like V2? There's a min tick and a max tick GUIFL, which represents like the maximum possible price space. So it's not technically zero or technically infinity, of course, but like it's enough to be reasonable. So yeah, you can do that if you want. Is the no delegate call check purely a square protection, or is there some other consideration? It doesn't let you delegate call into the contract. I'll just put it that way. It seems like staking reward contracts will have to change how they distribute rewards. Yeah, that's true. It's actually a little it's not trivial anymore. So yeah, the way it works is basically you have to track. You can incentivize price ranges. You can incentivize particular positions. There's lots of ways to do it. I think probably the simplest way is to track a particular price range that you're interested in incentivizing, and then giving people rewards based on the amount of time their liquidity was active in that range, which you can do via this seconds outside array that we store for every tick. So every tick has this like seconds inside or outside data that basically lets you, for any range, calculate the amount of time since the last time you checked the price has been within that range. And so that lets you basically incentivize like do liquidity mining if you want for a particular price range. And then you can do that like pro rata for how long your position was in the range or whatever. But yeah, we haven't written those yet, and it's a little complicated. But yeah, we're expecting people to do that as well, because it's like a common thing to want, right? Thanks, Noah. It's still possible to V2 style checkpoint the accumulator. Yeah, so in fact, you definitely can just checkpoint, right? Like if you need more than 9 days or the Oracle array like isn't long enough yet, you can definitely still checkpoint, and the accumulators are still going to be like totally valid. It's just that if the array is long enough already, you don't need to have like counterfactually checkpointed back a day ago or 2 hours ago or whatever, in order to sort of like get the average price. So is pulling historical volatility from the protocol still possible with V3? Yeah, so you can again just calculate historical volatility super easily with an Oracle array, right? Yeah, so it's very easy. That's all there is to say. Now that positions are NFTs, can someone do like NFTX to swap LP NFT into ERC20s? Yeah, I mean NFTs are going to be like fully, they're going to be fully functional. You're going to be able to like permit them, approve them, transfer them, bundle them, all kinds of things. So yeah, we're expecting that to be one way of fungibilizing positions, but possibly it makes more sense to let NFTs be the sort of non-fungible position representation, but then let there be sort of a variety of fungible ERC20 strategies that have fee investment sort of built in, you don't even need an LP position, or sorry, an NFT position directly. You can just sort of directly contribute to this fungible ERC20 position. So that might be the case as well. Should post this recording on YouTube. Yeah, it'll be a Twitch VOD, but I'll probably save it as well. I couldn't find a read function that's equivalent to get amounts out in the router. Yeah, so Dingus, it's basically, so yeah, I didn't even really answer your question. I just sort of went over the general overview. So there's actually no function that does that right now because it's prohibitively expensive. Because what happens is you have to essentially traverse, well, it's prohibitively expensive on chain because you have to like fetch a bunch of these, you essentially have to replicate the while loop in your own quoting function, in your own quoting contract. So the way we're thinking about doing this, and it's a little janky, but you basically swap however much you want. Like you want to quote, 100 DAI, like what's my output amount? You send in 100 DAI to the contract, or you pretend you did. You get quoted an output amount, and then inside the callback, the callback that is responsible for paying the 100 DAI. You like read the output amount of ETH, say, that you got from that 100 DAI, and then you revert, so everything like goes back, and then you return the ETH amount as like the error from the revert, and that lets you like get a quote without having to implement the logic. So it's a little janky. We're thinking about the best way to do this, but realistically, you don't actually ever want to quote on chain. It like doesn't really make sense. You only ever want to quote off chain, and off chain will have an SDK that'll do this for you. And if you really need to quote on chain, you can do what I just said, or you could replicate all the logic and just like make a bunch of calls to fetch data. But that's sort of how we're thinking about that. How do you calculate seconds? Yeah, it's based on, Ethereum gives you timestamps. Why not Viper? Yeah, Viper is just, we don't feel that it's like mission critical ready yet. We don't want a compiler error to be the reason that v3 doesn't work. What are some things you think the community can build on top of Uniswap v3? So many things. Yeah, I've mentioned a bunch already, like Yearn style auto rebalancing, Oracle projects, swaps that can now like use the Oracle array to like automatically and safely convert assets on the schedule, like dollar cost average style. Yeah, there's so much stuff that people could do. Yeah, I mean that's only the tip of the iceberg. Will you deploy to Starkware? Yeah, no public plans about that yet. Only optimism so far. How much gas does low gas safe math really save? Funny, yeah. This is Moody, my co-engineer's. Actually, sorry, let me just quickly check that out. I gotta go pretty soon, but I think we're good for a few more minutes. Yeah, so Moody, my co-engineer, did some great optimization work, and among that was low gas safe math, which is like a gas optimized version of Open Zeppelin's, and it's mostly gas optimized from the perspective of like we don't have error returns, which costs a lot of bytecode and gas. So I don't remember off the top of my head how much gas it saves, but enough to be worth it. So cool. Let me show you guys the snapshots actually. Gas snapshots, because this is pretty fun. So the pool here, I think it's this one. Yeah, so basically the lowest possible cost swap is this 104K. So this is pretty good. And yeah, that's basically like the floor for swap gas costs in V3, which is a little less than V2. And even if you cross some ticks, like with a big swap that crosses like 2 or 3 ticks, the cost only increases by like, it's about 15K per tick, right? So this is a plus 15 here. And so the most we expect most trades to cross, the most ticks we expect most trades to cross is 2. So 2 tick crossings is 136K gas, which is still like really cheap. So we're pretty happy about that. What's up, Kinzrek? I've never actually said that out loud. Kinres C. Anyway, hey. The spec is the white paper. Yeah, uniswap.org/whitepaperv3.pdf. And then there's the blog post as well. Pretty cool. And here, there's this little tool you guys can play around with, which does a much better job than my VS Code drawings of showing capital efficiency and how these ratios, like this capital efficiency multiplier, works. What about licensing? So yeah, the license is business source, and it's a time delayed GPL2 or later. So for the next 2 years, you cannot use much of the V3 core code in a commercial application. And after that, it reverts to GPL2 or later. And yeah, I think that this sort of paragraph explains pretty well. And I am a super GPL maximalist. I write a bunch of personal software that's GPL, and I've pushed for a lot of GPL stuff internally in Uniswap, and I'm quite happy with this. So, you can take that as it is. No problem, Khalid. Thanks for tuning in. Can libraries like math and Logas be used with BSL? Yeah, so we were really careful to license things that other people might need to integrate with V3 permissively, or like meaning GPL rather than BSL. So the things that you might need if you're an integrator are like bitmath or fix.96 or fix.128. And as you see, these are all GPL2. Full math is MIT, thanks to Remco Bloemen from 0x. Liquidity math, GPL2 or later. There's only a very few libraries and pieces of code in V3 that you need as an external integrator, and all of those are already licensed as GPL2 or later. And then additionally, everything in the periphery is also GPL2 or later. So yeah, there's really if there's any part of the V3 core code that you need, it should already be licensed GPL, and you shouldn't even have to worry about the business license. The business license is solely for pieces of code that are like responsible for the, what you should be treating as the black box of V3, right? So protecting that while loop with your life. Yes, the while loop is our pride and joy. Cool. Okay, so we're getting pretty close to wrapping up here. I guess I'll just plug really quick the periphery. So yeah, the periphery is also really interesting. The core is like a whole gargantuan thing. I barely even scraped the surface. We didn't even dive in as much as I sort of expected to necessarily. But if you're just sort of interested in maybe understanding V3 on a high level, and then you want to maybe think about applications, I definitely recommend checking out the periphery because it's significantly less complicated, and it does more or less treat V3 as like this black box that I mentioned. And so the core contracts to mention here are the top level ones again. We've got a swap router, which is responsible for swapping in V3. We've got an NFT manager, which is responsible for like position management, right? And then we've got this migrator, which is responsible for taking liquidity from V2 and putting it into V3. And then one thing I actually didn't even cover, and I see there's more questions, I'll get those in a sec. I didn't even cover how you pay for things in V3. So you pay in V3 when you're swapping an input amount, or you need to pay that. How do you do that? That actually happens now via a swap, via a callback, where you the core contracts call back into the caller of the swap function, for example, and they say, hey, pay me X. And then if you pay, great. And if you don't, the contract reverts. So it's a pretty interesting pattern. There's a lot of benefits. The basic big benefit is that you don't have to, you don't have to like transfer from in the core essentially. And the callback is a really neat way of like doing balance checks to ensure that you have been sent the requisite amount to sort of handle non-compliant tokens. So yeah, that's a pretty interesting pattern, and you'll see that being used in the periphery. Okay, what are the error codes? Is there a way to get more info? Yeah, so the error codes in periphery are actually pretty good. Too little received, for example, not bad. In core, because of bytecode gas golfing reasons, we were really minimal. So I feel a little bad actually, because things like L aren't that descriptive. But hopefully, our tooling is hopefully going to like prohibit you from doing most of the things that would run you into these like obvious error codes. And the ones, the situations where you do run into an error code are going to be like clear enough. Like it's basically just that you didn't pay enough, or like that your trade failed because of slippage. And so yeah, these are hopefully descriptive enough for like devs and things to sort of know what went wrong. And then these periphery error messages are like hopefully a little more descriptive and like tell you what, they just give you a hint to why your transaction failed. What are the... Okay, I'm not going to go over that. Do a follow-up Twitch stream. I might, Miguel. Yeah, I didn't get to nearly as much as I wanted to, and if there's interest, I'm more than happy to. Maybe just ping me on Twitter if you guys are interested. Is the famous reverted out of gas error fixed? Possibly failed swaps. Yeah, so unfortunately, failed swaps are always going to be a thing. We're going to try to minimize them to the extent possible. But yeah, ultimately, like if your trade fails because you got front run, that's a good thing, right? And you should probably in most cases be happy that you didn't get an awful rate, right? But it's a little unfortunate, of course, that we live in this like sort of adversarial environment, and so it's always a balance. But ultimately, we can't like fix, we can't fix like people behaving such that your trade fails. If the price moves, someone arbs it, and then your trade goes through and it fails because of slippage, like you sort of have to just try again. But there's a lot of ways to mitigate this, and I think the gas stuff is going to help. L2 is going to help. Lower price impact is going to help. So I think there's definitely there's definitely ways around this trade failure issue. Who do you expect to use non-fungible position manager? Well, everyone so far. Yeah, you can manage, and you can do stuff in batch. I should mention that like the periphery has this multi-call contract. Oops, it's in base. Multi-call. So yeah, it lets you just delegate call the address a bunch of times in a loop. And so yeah, you can create, manage, burn, etc. any number of positions in a single transaction as anyone. So yeah, it should be every individual LP should probably or will probably be using this to start, and then we're expecting fungible positions to sort of pop up, and then and they'll have their own sort of semantics for for updating and rebalancing and fee collection and all that. Sweet. RIP's insufficient A amount. Yeah, that's now the insufficient A amount is where is it? It's not even, yeah, it'll be some crazy thing. I don't even know what it's going to say. In theory, it's going to be caught by this, and it'll say too little received, or it'll say too much requested. But yeah. Can migrator migrate sushi LP to V3? Well, the migrator will work for any pool pair, I guess, in V2 that is compliant with the V2 interface. So put it that way. Interface meaning smart contract interface, like the API. Okay, everyone, you were great. It's 3:15. I got to work a little bit. This is super fun. I hope it was fun for you guys. It's fun for me. First Twitch stream. I'm going to pause the lo-fi. Cool. I'm going to sign off. If anyone has any questions, hit me up on Twitter. I'm super down for doing another one of these. Maybe I'll bring Moody into one if you guys want to hear from him. Yeah, we're more than happy to ask questions. There's going to be an AMA tomorrow in the Uniswap Discord. We'll probably tweet about it, so maybe just follow Uniswap on Twitter. I'll try to tweet about it as well. I think it's like 2 p.m. Eastern or something, maybe even the same time as I started. So yeah, hit us up for that. And yeah, just stay in touch. And we're super excited about V3. We hope you guys are as well. Yeah, thanks everyone for tuning in. Clap, clap, clap. Awesome. More soon. Thanks, everyone. This is really fun. And I will see you all soon. Hopefully at another Ethereum meetup. All right. Bye, everyone. Cheers.